Welcome to the DIY Honda Garage channel. This presentation covers the diagnostic trouble codes DTC U0100 and U0122 for the Honda CRV models from 2017 to 2022. These codes indicate a communication failure between the body control module BCM and two key components: the engine control module ECM or powertrain control module PCM and the vehicle stability assist VSA or anti-lock braking system ABS. Such issues can lead to impaired vehicle performance and safety functionalities. This guide will detail the steps needed to identify and rectify these errors effectively. Proper diagnostics are essential to ensure that the BCM has stable communication with all necessary modules, leading to accurate functioning of the vehicle systems. DTC U0100 signifies that the body control module BCM has lost communication with the engine control module ECM or powertrain control module PCM. Conversely, DTC U0122 indicates a communication failure between the BCM and the vehicle stability assist VSA and anti-lock braking system ABS. The BCM plays a central role in managing various electrical systems within the vehicle, ensuring that the ECM and VSA receive necessary data to optimize engine performance and maintain vehicle stability. These components are typically located under the dashboard, with the ECM near the engine compartment and the VSA ABS module integrated into the braking system. Issues such as poor connections in wiring harnesses or defects in these control units can trigger these DTCs, prompting further diagnosis and repair. Several factors can result in DTCs U0100 and U0122. A common cause is a grounding failure at the control unit, which can disrupt communication between the BCM and other modules. Grounding refers to the electrical connection that allows current to flow safely through the vehicle's electronic systems. Another potential cause is a power source failure at the control unit, leading to the inability of the BCM to send or receive signals. Additionally, faulty connectors or terminals can create interruptions in the signal pathways, causing the communication errors identified by these DTCs. Identifying and rectifying these faults is essential for restoring proper communication among control units. Drivers may notice various symptoms when experiencing the issues associated with DTC U0100 and U0122. The most evident symptom is the illumination of the check engine light, alerting the driver to diagnose the issue. Moreover, erratic vehicle behavior may be observed, including unresponsive or delayed actions related to the engine and brakes. In particular, failures in the VSA or ABS systems can lead to compromised vehicle stability, especially under challenging driving conditions. Such symptoms indicate a need for immediate attention, as they could potentially affect driving safety and performance. Recognizing these signs early can lead to prompt diagnostics and repairs. The first step in troubleshooting DTC U0100 and U0122 involves using the Honda Diagnostic System, HDS, to clear any existing DTCs. Clearing these codes resets the system, allowing for a fresh check on the current status of the vehicle's electrical systems. After clearing the DTCs, turn the vehicle ignition to off, lock, and then to on mode again. This action primes the system for a new diagnostic assessment. It is crucial to wait at least 6 seconds before proceeding to check for DTCs again. This waiting period ensures that the vehicle systems have sufficient time to complete their initialization processes, allowing for accurate readings. In the second step of troubleshooting, you will check for any DTCs associated with the CAN, Controller Area Network, Gateway System. This is also conducted through the HDS. The CAN gateway is critical for facilitating communication between different control modules in the vehicle. you will need to look for relevant faults such as DTC U0029-00, U0047-00, or U3000-49, which indicate bus communication errors within the CAN system. Presence of these codes signifies the necessity to troubleshoot the CAN gateway further, as they reflect issues that can complicate the data exchange, thereby affecting the overall vehicle function. If no CAN gateway DTCs appear, you can proceed to the next troubleshooting step. The next step is to perform an FCAN circuit communication check, particularly focusing on the receiving control unit. This is done via the HDS by selecting the function test within the CAN gateway settings, followed by the FCAN bus connected unit check. It is imperative to determine if the body control module, BCM, can detect the CAN gateway bus channels A. If bus A is unavailable, further investigations about the communication pathway must be conducted. Conversely, if it is available, you will proceed to check additional connections and potential failures at the transmitting control unit that may lead to further communication issues. This process is vital for pinpointing the location of potential failures. Step 4 involves checking the FCAN A lines for any open wires. Start by turning the vehicle to the off lock mode and disconnect specified connectors, the CAN gateway 12P and 16P connectors, along with the body control module connector B, 36P. Once disconnected, you need to measure the resistance between designated test points to identify any interruptions in the wiring. When performing these measurements, ensure the vehicle is in the off mode to avoid discrepancies. If the resistance reads 1.0 ohms or less between the specified points, the FCAN AH and FCAN AL wires are functioning correctly, which means further investigation may be needed elsewhere. If the resistance is higher, there is an open circuit that requires repair. Following the open wire check, the next troubleshooting step entails performing another FCAN circuit communication check. Again, you will utilize the HDS to access the function test in the CAN gateway and select the FCAN bus connected unit check. Here, you will check if the transmitting control unit, like the ECM or VSA modulator control unit, detects the CAN gateway bus channels as normal. If the system shows no detection under DTC U0100 or U0122 for channels A or B, it indicates further communication failures. Identifying such failures is crucial because they may be linked to loose connections or faulty terminals that are interrupting signal flow. If normal detection occurs, the system might simply be experiencing an intermittent fault, which is typically less severe. Step 6 calls for another open wire check specifically on the FCAN A lines. Start by turning off the vehicle and jumping the SCS, shorting connector sensing, line with the HDS. This action will allow for testing without interference from other control units. Afterward, disconnect the appropriate transmitting control unit connectors based on the indicated DTCs, such as the PCM or the VSA modulator control unit. Continue by measuring the resistance at specified test points to verify connectivity. If the resistance checks out at 1.0 ohms or less, the FCAN A connections are confirmed to be okay. You will then proceed to potentially replace the relevant control unit. Conversely, if the resistance indicates a larger reading, it highlights the need for repair on the FCAN AH or FCAN AL wires. In Step 7, conduct an open wire check on the FCAN B lines. Begin by ensuring the vehicle is turned off and perform the SCS jump again to negate interference. Similar to previous steps, you will need to disconnect the transmitting control units relevant to the detected DTCs. Measure the resistance between designated test points for the FCAN BH and FCAN BL wires, achieving a resistance reading of 1.0 ohms or less indicates that these wires are functioning correctly. If this reading is not satisfactory, it signals that there are open circuits that require addressing. Based on the DTCs, you may suggest replacing the control unit to resolve ongoing communication issues at this stage. The final troubleshooting step focuses on verifying the FCAN-H and FCAN-L lines. Start by turning the vehicle off and disconnecting the body control module connector B36P. Remember to perform the SCS jump again to prevent diagnostic discrepancies. You will also need to disconnect the relevant transmitting control unit connectors based on previously indicated DTCs. This includes essential connections necessary for assessing the integrity of the lines. Using a multimeter, measure the resistance between the receiving and transmitting control units on both FCAN-H and FCAN-L circuits. A reading of 1.0 ohms or less confirms that the wiring is operational. If there is higher resistance, it signifies that the wires may be open, necessitating repairs before clearing the DTCs. After completing the troubleshooting steps, it's crucial to verify the repairs made. Start by clearing the DTCs using the Honda Diagnostic System, HDS, and check to ensure that no DTCs are present. Verify that the vehicle systems are functioning correctly, including the ECM and any controls linked to the VSA ABS. A road test may also be beneficial in assessing practical performance and verifying that the vehicle operates smoothly without triggering any warning lights. This verification stage is essential for ensuring the problems have been adequately addressed and that the vehicle maintenance adheres to safety standards. For long-term reliability in avoiding DTCs U0100 and U0122, implementing preventive maintenance is vital. Regularly inspecting electrical connectors and ensuring they are clean and free of corrosion can significantly reduce communication failures among modules. Keeping electrical contacts clean helps in maintaining optimal signal integrity. It is also advisable to perform periodic software updates on the control units. This can enhance performance and provide bug fixes that might prevent these communication errors from occurring. Additionally, inspecting the vehicle's electrical system during routine maintenance can aid in identifying potential issues before they develop into significant problems, thereby ensuring the longevity and reliability of the vehicle's performance. In conclusion, ensuring clear communication between control units in the Honda CRV is paramount for optimal vehicle operation. The diagnostic trouble codes U0100 and U0122 highlight critical issues that can impact safety and performance. Regular diagnostics and maintenance can help in early identification of these issues, averting more severe complications. Awareness of the symptoms associated with these DTCs enables proactive measures, ensuring vehicle stability and safety for users. Therefore, implementing recommended troubleshooting strategies and preventive maintenance will lead to improved vehicle performance and reliability in the long term. Please like and subscribe to the channel. See you next time.